Okay, so the objective of this activity is to understand how characters and character state changes, we just talked about, are used to construct cladograms. And our cladograms, again, aren't quite phylogenetic trees, but they're simply trees that show recency of common ancestry, just how things are related. There's no real other data involved besides our characters and character state changes that are associated with that tree. So I've already divided you into 5 groups. I've passed out a jaw. Note that those jaws are much bigger than natural size. We're dealing with Mesozoic mammal jaws. And so these are, again, would probably be normally about ½ an inch long or so, but instead we've blown these up so that you can look at them and give me some models. And what you're going to do is on a piece of paper, if you don't have paper, that's all right. You can also just use, pull up a program on your computer, Microsoft Word, and put 6 label or number 1 through 6 on a piece of paper. And then I'm going to give you 6 characters. And for those 6 characters, all you have to do, real simple exercise, is score 0 or 1 for absence or presence of that character on your jaws. And I'll provide those here in a second. And I'll walk around, I'll give you your group a few minutes to do this, and I'll help you out, and you can ask any questions you have on this. And a couple of them are tricky, so if you have any problems, that's fine, that's expected. And then once your group is finished, we'll go over to the board, and let's say here we have group A. So you got the A jaw labeled on there, and on the A column, you'll score 0s or 1s for all 6 of those characters. So we want to take about 5 minutes to do that next. Okay, so the first character is simply absence or presence of a coronoid process. And so the coronoid process is this. Here's the jaw joint right here. And you should have, most of these, or maybe all of them, have 3 processes in the back of the jaw. One here, and then the jaw joint, and then this higher process. So if your jaw has that, you give it a 0 or a 1. Give it a 1. Okay, I'll quickly run through the other 5, and then I'll let you guys talk amongst yourself. The second character, the 3 tallest cusps form a triangle when you're looking down on those. So the molars, the last teeth, they form a triangle. The cusps form a triangle on those when looking down. The incisors, usually the largest tooth up there is the canine. Anything in front of that are incisors. You can count the number of incisors. If there's less than 4 incisors, then you would give it a 1 for presence. 3 main molar cusps and a small shelf behind the cusps. Some of these will have a little bit of a cusp or a little bit of a shelf behind. And then these last 2 are a little more confusing because they're kind of a double negative. Jaw lacks a postdentary trough. If it lacks a postdentary trough, you actually give it a 1 for presence. And that trough is kind of a groove, a deep groove in the back of the jaw. Some of these might have a real deep groove, and then others may have just a real faint groove or small groove. We call that Meckel's groove. So postdentary trough or Meckel's groove. If it has a postdentary trough, it would also have Meckel's groove. So those should both be 1s if you have that. Okay, I'll give you guys a few minutes to work.
The last ones should be ones that you don't have, right? The last 2.
Yeah, if you lack, you actually have the presence of 1. So it's a little, yes, presence of lackingness. So it is a little confusing there, but it's, there's a reason for that.
Science is infallible. I have no idea what you're talking about.
I thought we like both of them, just like very like.
What?
It's less than 4.
Oh.
It's less than 4.
Well, he was saying he was looking at like.
Yeah, so
I don't know.
Yes.
Maybe it's not hard.
But you don't really have 3 distinct for the tall cusp. You have 1 distinct tall cusp here, and then you don't have 2 others that match. So I would say
Well, number 4.
Yeah, it looks like that's where
There's like a flat line.
Total, as in should be Okay, for less than 4 incisors, do you mean less than 4 incisors on each side of the jaw, or less than 4 incisors?
Just on the jaw unit. Yep, that's a good question.
So then,
Yeah, you're only looking at your jaw, so the incisors would just be on your, we call it hemimandible, half the jaw, left or right.
This is the outside. This is the inside.
This is, yeah, it's pretty smooth.
These are the incisors. These are molars, and that's where you
oh, okay.
So yeah, character 2, you would use these, and then character 3, you would use
All 3 of them processing coronoid.
So we said that so the trophic groove.
I would like to see it.
Yeah, if Cluedis could pass that down at some point, that'd be great.
You see no grooves, no trunks.
Okay. I was just so, yeah, I can see what they're talking about, the shelf, which we decided.
Yeah, like if they be on the
And the other one was the 3 tallest cups.
no, they are. If that was like
Yeah, it's really
That's also a good idea.
I was looking at the
I believe so. We'll see how I scored it.
Yeah.
See if it matches.
Thank you. It's just like that.
Is it one?
Yeah. That jaw is very smooth, so I think we're good on having it and then draw it in a 3D program.
It's got smooth bones. What can we say?
That's fine.
Yes.
That's a good question, because it doesn't have that distinct lower process, so I should have clarified that, yeah. So yeah, that's definitely very large.
These are 3D printed that cover up the.
They're actually on the inside. Yeah.
Would this be considered
Yep, you're right on. And there's, yeah, no trough on that, but there is a little bit of a groove there. So, yep, you have a metal groove. So
It's pretty fun though when you take
it's a
little
double
things,
negative.
you
So,
blow them up and then print them large. It's like all kinds of crazy things.
yeah, so yeah, one for 5 and 0 for 6. Is that right? If your group finishes, even if you're not real confident, if you want to put your guesses or your scores up on the board for us, you want to put that
It's pretty easy. Just draw a line. Just draw a line from the whole thing.
So we could double check that, but it doesn't really look like it.
Yeah, I think
So you don't have
it would be more of a deeper, like a
Yeah.
so we have one for Christ to start.
And then we'll be.
That's got the 1.
0, then 1, then 0, then 1.
That's the reason I'm saying why I'm so close to enter a trunk of those words.
So just the first and last one?
Yeah.
I always do the front legs, and I was like, this is hilarious. So I always do the front legs, and now it looks like a long,
So if we're looking at this, and now we want to reconstruct our cladogram from this data, are any of those characters not helpful? Coronoid process, why is the coronoid process not helpful?
They all have it.
They all have it. We can't distinguish certain taxa from one another because we don't have some that have lost or gained it. Is there any others that aren't helpful? The very last one. Why is the last one not helpful in this case? There's only one has it. So if we plot those on a phylogeny or on a cladogram here, what we're going to end up with is a polytomy. If we only look at those 2 characters, we're going to get what we call a polytomy, where everything's branching in the same spot because we cannot resolve that tree. We cannot resolve those relationships. And if we put those characters on here, what would go down here on our cladogram? Coronoid process, because everything has it. But only one taxon, or one OTU has the lacks the Meckel's groove there. So this would be taxon C that would fall right there. That's all we figured out, is we know that these match up. This one matches with C, that character state change, but we haven't resolved the relationships really in that tree. Now I just want to clarify, because my next figures are going to look blockier like this, that this equals this, even though they look different. We have one node here where everything branches from that. Okay, if we go back to that data, which taxon is likely to be the earliest branching in our cladogram? Branching off the earliest from the rest of the group.
D.
D. Why do we say D? Yes.
D is the only one that lacks characters 3 and 5.
It's all zeros except for that one. It has the most primitive characters. We tend to score the zeros, or absence of, as usually the primitive state, and then the ones as the derived state. So this is the most basal, most likely going to be the most basal on our cladogram. So now we've resolved it a little bit. We've moved D over here, but we still have a polytomy over here. We still have unresolved, 4 unresolved taxa over on this side. This one has a, I believe that was the one, maybe, yeah, the D, that one had a trough back here. It wasn't real distinct trough, but it's where the middle ear bones actually fall. So this is before the evolution of the separation of the ear bones from the jaw, like we see in crown mammals. That leads to our marsupials and our placentals that were talked about today. So this is the closest relative of the 5 jaws. That would be the closest relative to most of the mammals alive today. So the next thing we want to investigate is the measure of tree support in this data, from that character data. And so this is called the consistency index. And what we want to do is divide the number of characters divided by the number of character state changes. So how many characters do we have?
6.
How many character state changes do we have on our cladogram here? Six. It's not quite that simple though. Remember, this character wasn't helpful? This character wasn't helpful. We started that off by saying they don't do us much good. So instead of 6 divided by 6, it's actually going to be, in this case, 4 divided by 4. It's going to give you a value of 1. That's the maximum value you can get for the consistency index. It means there's no homoplasy, there's no convergent evolution of these characters. So that's pretty simple here. We just took our 4 characters that were meaningful, divided by the 4 character state changes, but of course that can get a little bit more complex. So let's say, for example, that shelf, it kind of looks like D had a bit of a shelf behind the cusp. And let's say that we score that as having a bit of a shelf back here, just like A and C did. That would be an example of homoplasy, convergent evolution, 2 groups evolving the same traits. And if we scored that, this character change here, what's our new consistency index? What would be the first, how many characters would we have? We'd still have 4. How many character state changes do we now have? 5. So our consistency index has dropped because of that homoplasy, because of that convergent evolution, and now it's dropped to 0.8. And if we had more examples of this convergent evolution, then it would drop even more. Okay, one last point I want to make before I let you go here, and if anybody, I know time's up, I think, for class, so if anybody has to leave, they're welcome to. But one quick note is that we still have a problem